All right, what's up, class? All right, today I think we will have more of a short lecture. I'm only going to really be talking about two things, and it's going to be about pulleys, two different types of pulleys. All right, so jumping right into it. So what is a pulley? Well, a pulley is basically a contraption that uses a string and connects two masses, right, of different mass, M1, M2, and the string can travel across the pulley and move each either mass in this scenario up or down. If M1 is greater than M2, the green, then the acceleration of the pulley, the entire system, will be downwards to the right. And you can see that, so essentially, the green block will go up and the red block will go down. So here it's important to know what movement is. All right, because if we draw, let's say, a free body diagram, let's do this one for M1 and this one for M2. I should do this one in green. All right, if we have M1, then we have, okay, so M1's right here. We have the force of gravity, Fg, and the force of tension, Ft. In this scenario, down it should be positive. Why? Let's do M2's. M2 has the force of gravity as well as the force of tension. And in this case, up is positive. Now that actually makes sense because in the M1 scenario, moving down is the same thing as M2 moving up. If M2 moves down, M1 has to go up. Whereas if M1 were to go up, M2 would have to go down. That's just how a pulley works, right? Because these two things are connected by string, if you pull down on one of them, the other thing goes up, right? In both scenarios, Ft is equal to each other. These two are equal, right? And these Fg's are not equal because this is M1 times G and this one is M2 times G, all right? And because M1 times G is larger than M2 times G, we showed it right here. Because of that, the force of gravity is larger, so it'll be forced down. Whereas the force of tension is going to be greater than F of G here. All right, so let's do this. These problems can get kind of tricky because you have to think of it as a system. If you have the pulley system without the pulley, right? M1, M2, and you let go. All right, I just redrew it without the colors this time because let's say this is all in a system. Instead of thinking it as one block here and another block here, the entire thing is the system. And then you let go of the pulley and it's going down that way, right? So how can we find the acceleration of the blocks given that we have the masses? Let's say M1, okay, let's bring it down here. Finding acceleration. Let's say M1 is equal to 10 kilograms. And let's say M2 is equal to 5 kilograms, right? Well, let's see for each block, we know that we have a acceleration that's going to go down for M1 and up for M2. Okay. Now, let's see. If we have this, we've already drawn the free body diagrams up here. Let's do this sigma F Y M1 and sigma F Y M2. All right, and this equals M1A M2A. That's the second law of motion. So this is Newton's second law. All right, it's stating that M1A is equal to the force of M1. All right, what were the forces on M1? Well, M1 had force of gravity minus the force of tension. M2A had the force of tension minus the force of gravity. All right. So now we know that the forces of gravity on each of these are different. Let's move this to the right. And this is equal to M1G minus Ft. All right. And this one is equal to M2G, wait, no, F of T minus M2G. Okay, so now we have something to solve for M2 and M1 as such. But we don't know, so let's see what we don't know. We know M1, we know M2. So we know these. We don't know acceleration, but we know M1G and M2G. So basically our two equations, we have a two variable equation. And you need two equations to solve for a two variable equation. Because if you had y equals 3x plus 4, you couldn't solve for it. But if you also had y equals 4x minus 9, you could substitute and find one of the answers, right? Well, we can do the same thing here. It's the same principle. It just looks more complex. Let me rewrite it. M1A equals M1G minus Ft. And that means M2A equals Ft minus M2G. Great. We can actually just straight up solve for f of t. So in this scenario, Ft equals M2A plus M2G. That's the force of tension. All right? Because in M2, the force of tension is equal to the acceleration plus the force of gravity. So we're just doing some algebra here. Now, let's take this f of t and plug it into here. Now we get, in green, M1A equals M1G minus M2A plus M2G. This is where physics gets kind of variable heavy. And we can see that all this is we can erase these parentheses. Can we? Let's see. No, we would have to do a subtraction sign here. All right. Well, that might confuse you, so let me just do that in 2 steps. All right. So we substituted for Ft here, and we get M1A equals M1G minus M2A minus M2G. The reason that you have to do a minus here is because there's actually a invisible -1 in front there. And if you distribute those, then this becomes a minus. So now, well, we need to solve for acceleration, right? So let's add M2A to both sides. Now we get M1A plus M2A equals M1G minus M2G. So now we distribute acceleration. A times the quantity m1 plus m2 equals m1g minus m2g divided by m1 plus m2, which simplifies, well, you can't divide just yet. So that means that A equals m1g minus m2g divided by m1 plus m2, which also equals g, the force of gravity, times the ratio m1 minus m2 divided by m1 plus m2. There. It's as fun as that. So that's how you solve for the acceleration. And now, does that make sense though? Why does A equal gravity times m1 minus m2 divided by m1 plus m2? Wouldn't it more make sense on a pulley, right, to just subtract the masses? Well, you can't really do that. So this part, the numerator, this is the subtraction part. It's saying that the acceleration is one mass stopping the other mass because of weight. One mass's weight will stop the other mass's weight, right? But what is this part? The numerator is logical, but why is the bottom part there? It's because the acceleration as one block goes down, it's not just one block moving. If one block goes down, both blocks have to move. So you have to divide by the total mass of two blocks because you're moving two blocks, essentially, right? That's why the acceleration is determined both on the subtraction of the two masses divided by the addition of the two masses. So this solution, this worked out solution in full, is pretty important to be able to do. I would review this solution multiple times. If you don't get it, I would come to office hours and check it out. But if you feel free to ask me any questions. We're going to explore more about pulleys, and the questions are going to get more and more cruel. But I don't do this to hurt you guys. I do this to help you learn new things. That was called an Atwood machine, all right? Atwood machine. When you have a pulley and a string and two blocks or two masses, M1, M2, of varying mass, that is called the Atwood machine. We just worked out the Atwood machine problem. Now, let's say we have a table, right? Lord help me. Okay. Let's say we have a table, just like that. And then we have, now this is our pulley arm, as in the little round thing that connects the two. Right there, that's my animated pulley arm. Actually kind of looks like an eyeball now, so I'm disturbed, so I'm just gonna make it like that. Okay, all right. So a half Atwood machine is this. You have M1 here, and you also have M2 here. Okay, this is called a half Atwood machine. All right. Well, in our half Atwood machine, if we were to let go, let's say this was being held in place by invisible force, like a hand or something, and we let go, where would this accelerate? Well, this mass, oh, this just got closed up, Lord. All right, there we go. Well, this mass is going to go downwards because it has no other place to go. M2 won't go left, right? M2 has to go right. What's going on? Come on. Oh, okay. M2 has to go to the right, and M1 has to go down. So that means that the x-axis for M2 is equivalent to the y-axis for M1. All right? That's a difficult concept to understand, but if M1 is going down on the y-axis, then M2 needs to be going right on the x-axis. All right? So now let's draw the free body diagram for this on a rough surface, a rough table. Considering that this table is rough, let's make this M1, let's make this M2. All right, M2 has the force of gravity, the normal force of the table, and the force of tension from the pulley. M2 also has the force of friction. All right. Now M1 only has the force of gravity and the force of tension. Interesting. So now what we can do is we can also find the sigmas, right? That means that there is a sigma fx and a sigma fy, but this is only for M2. And for M1, there's only a sigma fy because there's no x directional forces. Now, sigma fx to the, let's say to the right is positive, so we are going to have f of t minus f of f, force of friction. And in the y direction, we have f of n minus f of g, right? And this equals 0, right? It equals 0 because the block M2 is just sliding on the table. Whereas this, the x direction, has an acceleration because the M1 goes down, which is M2a. For M1, in the y direction, let's say down is positive, we have f of g minus f of t equals M1a. Now there's some special things to this problem about the half Atwood machine. First of all, it's that friction exists. All right? Because friction exists, the special thing is, if we have friction in a half Atwood machine, that's the only thing that's going to oppose the acceleration. So let's solve for acceleration in a half Atwood machine. If we solve for acceleration here, we know that the x acceleration of block M2 is equivalent to the y acceleration of block M1. Because if we let go of block M1, it has to go down as M2 goes to the right. All right. Now, if we have this, we can find something that is equivalent to both sides, f of t. So let's solve for f of t here. F of t is equal to f of g minus m1a. I just did some rearranging in algebra. Now let's take this f of t and plug it in here. All right. Let me rewrite this down here first. ft minus ff equals m2a. So we have Fg minus m1a minus f of f equals m2a. Now let's see here. Fg in this blue case, this is actually equal to m1g. So let's substitute that. m1g. All right. Great. So now we have to solve for acceleration. How do we do that? We add m1a to both sides. So now we have mg minus the force of friction is equal to m2 plus m1 times a. We want to know the force of friction. What is the force of friction? Wait, I have to specify this as m1. There you go. What is the force of friction? We know that the force of friction is equal to the force of the normal force times mu, the coefficient of static or kinetic friction. We also know that the normal force is right here. And the normal force, if you rearrange this equation, you can set the normal force equal to Fg, which is also m2g. Right? So now we know the normal force is equal to m2g, which means that force of friction is m2g times mu. So let's do this. m1g minus m2g mu equals m2 plus m1 quantity times a. So that means the acceleration is equal to m1g minus m2g divided by m2 plus m1, which is also equal to g times m1 minus m2. Wait, I forgot the mu here. My bad. All right. m1 minus m2 mu divided by m2 plus m1. Now, it may look similar to the other equation we derived. A equals m2 plus m1. All right. Now, it may look similar to the other equation we derived, but in this case, you're not just subtracting m1 and m2. You're subtracting m1, and you're taking m1 and you're subtracting m2 mu. This will be a much smaller number because it is dependent on the coefficient of friction. Okay? Now, for your daily check-in problem, the second one rather, I want you guys to, given a half Atwood machine, if we have a half Atwood machine, right? Let's say we have this, and this is M2 and this is M1. Did I match that? Let's see. Yes, good. I've got to keep that constant or sometimes people get confused. If the entire thing, right? If you let go of M1, right? And the table is so rough that the blocks don't move, find mu S for mu static friction given that M1 equals 10 kilograms and M2 equals 25 kilograms. All right. So you can do all the work if you desire. The equation is right here, hint, to find it. But find the mu s, or the minimum coefficient of static friction, rather. All right. Interpret that how you will. All right. So that's the lesson for today. See you guys tomorrow again, where we talk about more difficult ramp and pulley problems. All right. Have a great one.